If you work in IT operations, you probably hate your job. Not because of the work that you do, but the stress that you have to go through each and every day. You suddenly start working on a Monday morning and everything turned red. And it's not some emergency, it's because your application running in production, in the live production environment, is going through some outage. Your users are complaining, your clients are complaining, and the person sitting above you, your manager, your supervisor, your director, everyone is screaming at you all at once. Now, in this stressful situation, either you can calm yourself down and start working on it, or you can find a better alternative to debug and to triage the issue then and there. You don't just have to put a band-aid on the issue, you have to identify it, mitigate, triage it, and then also make sure that it never happens again with the help of proactive monitoring, observability, and so on. So in this video, I'm gonna share you the step-by-step framework of how you can do that step by step effectively and efficiently, so that you don't have to be stressful anymore, so that your application come up healthy in no time. You find the issue and you fix the issue once and for all. And if you are new here, hello, my name is Piyush, and Cloud and DevOps is what I do all day long. And my channel is known for simplifying complex concepts into bite-sized chunks so that anyone can consume it, even a beginner have no issues in understanding that. So let's start with the demo. And in this demo, we'll be using a tool called Portainer. Portainer, if you have not heard of this before, I have published one video for that earlier as well, Portainer with GitOps, and it's really amazing tool to work with Kubernetes. So we'll be using the same tool, the same setup. If you want to set up, you can follow the other video. I will link down in the description, and you can test it out free of cost. Yes, it provides a 3-node business edition free of cost, so you can start using it. Okay, so here's my app. As you can see that it's down. It's not working. This is the load balancer URL. So to start the investigation, there could be one or more multiple issues. It's a microservice-based app with multiple services running, and there could be multiple issues, right? So to start the investigation, I'll start with logging into my Portainer dashboard. So Portainer is deployed on the same cluster, hence it has access to the cluster and its resources. So here is the cluster, and it's Kubernetes EKS version 1.31. Okay, it's a 2-node cluster and it's a production application running on it. It has, as you can see, 24 application pods running, deployed across 6 different namespaces. Okay, so click on the namespaces and you will see these are the user created or the non-system namespaces. But over here on the 3 dots on the right, if you can click on and check this, show system resources, it will show you the system namespaces as well, like Kube system, Kube public, and so on. Okay, and then there is a Portainer namespace deployed in which this Portainer application is running as well. Okay, now our application is deployed probably in a default namespace. So let's go and check it out. And as you can see, it has multiple pods running. So these are multiple services, and we can just start checking the health of the application by clicking over here on the left side, right? And let me just zoom out a little bit. So here's the service name or the application name. Image it is using application type, which is deployment in most of the cases. And then the status. As you can see, most of them are green. That means it is up and healthy. And then there are some which is red. Okay. So red, and it says 0/1. That means 0 out of 1 pod in a deployment are healthy. So there are some issues with the application which we'll be looking at. Okay, and on the next page as well, there are some applications deployed. So let's go back and start the investigation. First, we need to start with the front end. It's an e-commerce application, right? So it probably has deployed as a front end. So here is the front end pod that we can see. Or you can also check the services. You can go to networking from the left side and services and ingress. There are 2 options. This doesn't have any ingress, so probably it is deployed as a load balancer service. So let's check it out over here. And here we can see type is load balancer. If you want, you can apply filter as well. So filter type is load balancer, let's say. So there is one load balancer service. And here is the host name for that. So copy that external host name and open that in a new tab. Okay. So this is the correct URL, but the application seems to be down. At least the front end is down, that we know for sure. Okay, so we'll start our investigation from here, from the front end pod. Okay, so click on the application. This is the application deployment, which is front end. And as you can see, scroll to the very last, you see the pod, application container. And this container is in status ImagePullBackOff. Okay. And if you go up, you will see YAML placement and events. Click on events and you will see the latest events on it. So successfully reconciled, error image pull, failed to pull the image, pulling image, error image pull back off, and back off pulling image, right? So that means there is some issue with pulling the image. Whenever we see this error image pull back off or error image pull, that means there is either the issue with the secrets that are being used to pull the image, or the image name, tag, or the combination of those is not correct. So these are probably the only reasons why we get error image pull. So let's go and check the YAML from here. Okay. And let's go to the image section of the container, which is over here. And let's see if we are using any secret. So I can just use Control F, secret. Nope, there is no secret. So that they'll probably be using the public image. Let's verify the image name. Google sample, microservices demo, front end, v010.3. Okay, so there is a dot at the very end. So that probably be the issue. Okay, so we need to fix that. Click over here, which says edit external application. Okay, when you do edit external application, it will point you to the service, right? We don't want to update any service level details because the application image name is incorrect, right? So let's say if we want to update the load balancer service, you can do that from here, maybe changing the port or the annotation and so on. But we don't want to do that. So you can directly make the change over here in the YAML. Let's go back again and I'm just gonna remove it. And over here you see apply changes. As soon as you click on that, it says deployment front end updated successfully. That means it has applied the updated YAML with kubectl apply command, whatever we use, without actually using the kubectl command. It was really fast because we identified the issue, right? Now let's go back to the events. And now it says it started pulling up the image, started the container and scaled down to 0 from 1. Let's see. Okay. The application is running and then there is another container creating. Maybe it's coming up. So let's go back to application and now it says replica 1-on-1. Okay. So seems like our application came up. Here is the application container and that was the first issue that we fixed. So click over here and it's loading. Maybe the application is coming up or it has other issues as well. Okay. So we see one more issue now. It says 500 internal error, can't access card storage and unable to connect on this. Maybe some issues with the Redis card service. So let's go back and check the Redis card service to the applications. So there is card service over here and there is one more card service. But first let's check this one, card service. Okay. And this container is running. The pod is healthy. Replicated 1-on-1, it's fine. Let's check the event. I see some failures in props, liveliness and readiness prop, but that could be from before. And here are some more details. Let's go inside the YAML. Okay. And let's quickly verify because it is throwing error to connect with the server. So we need to verify the host name and we need to verify port number as well on which it is running, right? So service, so here is card service, okay. And then here is gRPC port 7070, which is the same in the service YAML as well. And then we have container Redis cart. Here is the image, okay. So let's verify if it is able to connect to Redis or not. So this is the container that we are mostly concerned with, okay, card service container. and this container is connecting to Redis, which is throwing the error. So let me open the Redis card application as well in the next tab. And over here, maybe on the next page, here it is, Redis card. And let's check the YAML. Okay, over here you see it is running on TCP socket 6379, and the same 6379 port is exposed on the container as well, right? So that means Redis is listening on port 6379, as simple as that. If we go back over here, you see we are passing the Redis address as 7070, which is incorrect. It should be 6379, and also the value of Redis address should be the host name of this container, right? Which is, sorry, the application name, which is Redis cart. And over here, I see some extra T. So let me just update this and apply changes. Okay, it says applied successfully. And now after that, it started the container, and container probably is running already. Yeah, still coming up. Let's hit refresh. Okay, let's hit refresh on our application. Still the same issue. Okay, let's go back. And it says still coming up, I think. Props are still not healthy. That's why the application is not healthy. So let's wait for a couple of more. Yeah, this. So application is up now. Now we see there was a front-end issue for which we updated the image tag. Then the second one was related to issues with the deployment YAML, for which, due to which it is not able to connect the Redis cart. So that issue has been fixed. Let's see what else does it have. So all the applications will be listening over here, right? And you will see whichever is red or whichever is not reporting healthy status. So this is good, and this is red, but this is a load generator application. So ignore that for now. Let's hit next. And then we have recommendation service, which is, I believe, based on, if you click on that, there should be some recommendation over here of the products, which is coming from the recommendation service microservice, but it is not happening. So that's another issue with the application. So how do we fix that? First, let's check the issue with the application. Recommendation service over here. Let's check the events. So events should be the first place, and then we need to check the logs. Everything is over here. You don't have to run any kubectl command, anything. It's really fast troubleshooting that you can do with the Portainer. So over here you see the props are getting failed. It says liveliness prop failed to connect to the service. Readiness prop also is getting failed, and then the container is back off restarting failed. It's stuck in the crash loop. If you go down, you see crash loop back restarted 23 times. So it keeps on restarting the container, but it is not coming up healthy. Okay, let's go to the YAML and let's check if we find anything in the YAML. So we have status. Status says minimum replicas unavailable, and replica said timed out progressing, progress deadline exceeded, and it is unavailable, but it does not show the actual reason why it is unavailable. So in those cases, what we can do is we can click over here which says kubectl shell, which is an inbuilt shell within Portainer. And yes, you don't have to do any authentication authorization because it is built in within your Kubernetes cluster. So it is already part of the cluster. Okay, so let's run kubectl get pods. So we need to check the recommendation service pod, which is over here stuck in the crash loop back. Okay, so I've copied the name. Now kubectl describe pod and the pod name. Now these are all the events that we have already seen from the Portainer UI. Did not have much details other than just props were getting failed. Now scroll up to the section, and this is where you will find the reason. It says last state terminated, error is 137. Okay, and reason is crash loop back. So 137 error, if you know, this is mostly OOM killed error. You can just check this out. Error code 137 in Kubernetes, not in LGTV, in Kubernetes. Okay, means the container was terminated forcibly by an external signal, and it received the SIG kill. Here are some of the primary causes for this error: memory limit reach, memory leaks, insufficient node memory. So it has something to do with the memory, and mostly this is OOM killed, which is out of memory exception. That means the pod needs more memory than it has allocated to, and the limits are also not enough for it. Okay, so let's go back to our Portainer section over here where the application goes inside YAML, and let's check the memory requests and limit allocated to recommendation service. Where is the recommendation service? Over here. Okay, and here it is. So you see only 16 MI memory and limits are allocated. So let's make some changes over here. So instead of 60, let's keep it 256 MI, and over here as well 256 MI, and hit apply. Okay, I've applied the changes. Let's go to the event and let's wait for some time because it's gonna restart the pod. So this one was the earlier pod that was in crash loop back. Now let's wait for some time, and you can trail the latest logs from here as well. You see over here there is a section called logs. Click on that and you will see the live logs. So it says initializing recommendation service, listening on port 8080. Looks it came up, but we'll verify that. And now it is showing as running. And scale down replica set recommendation from to 0 from 1. Let's go back over here in the replication, and now you don't see anything over here, right? Let's hit refresh. You see, you may also like this is coming from the recommendation service. So now recommendation service is also fixed. It was OOM killed because of the inappropriate memory request and limits. Every process, every container or pod needs certain amount of memory and CPU to run it properly. If it doesn't have, and if it has limits set but limits is not enough, it will go to crash loop back with OOM killed errors, which is what we have seen. So that's how we fixed it. And now let's go ahead and check the cluster health. So we have fixed the applications and seems working fine. And let's check if there is any other unhealthy application. So over here is everything is green, and everything is green over here as well. So yeah, no issues with this. Now let's go back over here and check the cluster health. Click on cluster details, and we see some CPU limits are exceeding. Okay, so we need to investigate why this has high CPU limits, and why it is taking more CPU than the other one, and which node is doing that. So there are two nodes. Click on one of the nodes. Let's click on the first node. Okay, over here we see it's taking around 85% CPU. Okay, let's see the applications running on this. So these are all the applications running on this, and these are all the CPU usage and limits that applied on each of the service or each of the application. Let's sort it with the CPU reservation and limits, and do that for memory as well. Okay, and let's see. So there seems to be this process, this pod, troubleshooting pod, which is taking around 500 MB of memory. And it's not a system process. It's not related to application because we know this was deployed by stack. Here is the stack. That means it's deployed by Portainer UI, and the name is troubleshooting pod. Someone created this pod for troubleshooting purpose and forgot to delete it, or it is just occupying the memory and overloading the node. So we need to take care of this application. We need to remove it, or we need to just make some changes to it, right? So let's hit over here to the YAML and let's see the utilization that it has. So it has one CPU as the limit, one GI of the memory and all. Yeah, so let's say we don't need this application, so we can simply delete this application from here. Okay, and where was it? So this application and troubleshooting pod. Okay, Do I have the option to delete it from here? No. Okay, let's go inside applications and look for troubleshooting pod over here, which is this one. Select this and hit remove. Okay, now let's go back and go to cluster details. Now it is coming down. It's 74 still, but it will come down in some time because it's just started releasing the memory. But if you check that node, and we don't have that service running anymore because it's been deleted. Okay. Yeah, so it will come down shortly. We can just wait and monitor it. Yeah, it's 59% now. So yeah, this come up healthy. Now we have identified and mitigated all the issues instantly. Now the next step that comes after it is observability. Like, how do we make sure that these kind of issue doesn't happen again, or we catch them before they actually creates an issue? For that, let's go to this section over here which says observability and click on alerting. Now we'll be setting up some proactive alert that will monitor the system, that will monitor the endpoints, and it will alert you in real time as soon as the issue occurs. Okay, so that you don't have to wait for client to report the issue. You can get the issue as soon as it occurs. Okay, so go over here which says rules, and there are all the rules that have been created. These are the alerts rule. Okay, so for example, backup failure, brute force attack, environment down. So let's enable environment down, and let's enable when high CPU utilization occurs or when high memory utilization occurs, right? So that you can get notified in real time as soon as the issue occurs. Okay, and how does it send the notification? First, let's configure these alerts properly. Okay, so click on edit, and it says environment high CPU utilization. Let's say whenever CPU utilization goes above 60% in 15 minutes or 5-10 minutes, you can get the alert. Okay, so let's keep it 60% in 5 minutes for now. Duration is 5 minutes over here, and enable this section which says the alert is enabled. Hit save. Let's do the same for memory. Alert when memory utilization exceeds above 60% in 5 minutes, and let's change this to 60. Conditional operator greater than 5 minutes. That's good. Hit save. Okay, environment down, you cannot edit it. It just monitors your Kubernetes environment. Yeah, let's enable these 3 alerts. But what actions are we taking once these alerts generated? So we need to send these alerts to somewhere, right? To some channel, to some notification channel, right? So click on settings over here, and you will see there is an alert setting. Click on edit. Okay, here is the name. First enable it, and then you can select the notification channel. So here is the notification channel for me, which is a Slack channel. And you can also configure it from here. So you can go to Slack API, and in the incoming webhook section, you can create a new webhook. Let's create a new webhook. Okay, select the workspace and then select the channel. Let's select the general channel, or let's select random channel. That's okay. Hit allow, and then copy the webhook URL from here and just paste that over here in the webhook URL section. Save settings. And yeah, so I have my Slack configured over here. So as soon as the CPU or memory reaches above 60%, I will get the notification in this random channel over here. Okay, it says added an integration. Just now I did that. Okay, so I'm gonna pause the recording and I'm gonna wait for the application to overload the server with more than 60% utilization for memory or CPU. So let's wait. Okay, so I have waited for some time, and as you can see, the alert has been popped up because the cluster has some production applications running. It is actively monitoring and consuming CPU and memory, and that is why it triggered the alert, as you can see over here, which says environment high memory usage 70%, memory usage exceeds 60% in 5 minutes, and all the other metadata related details. So if you can go back, maybe I'll just close the Slack for now. Okay, so if we go back over here and you can see in the active alerts, you will see the alert is active, which is memory usage is 71%, threshold was 60%, and it was just triggered, updated. You can either silence the alert or take necessary actions, which is like what I have shown you. Identify the application which is consuming more memory or CPU based on the alert, and then take necessary action. Maybe we need to adjust the memory requests and limits for that application, or if that application is not necessary, you can just take it out of the system. And here's how you can silence the alert as well. So add the comment silencing alert created by start and end date, it will be auto populated, and then hit create silence so that the alert will become inactive. Okay, then it will go over here in silence alert. Now we have silenced it for, let's say, 4 hours. After that it will become active again. Okay, so this is the way of acknowledging the alert. So yeah, that's it for this video. I hope you found this framework, the troubleshooting Kubernetes application framework, highly valuable. I have shown you step by step and few different errors that I was going through in my live production application, how to troubleshoot that, how to mitigate the issue, how to fix the issue, and how to make sure that it never happens again, or as soon as it happens you get notified so that you can take necessary actions on that. Okay, so try it out and let me know if you face any issues. Plus, I hope you have a good day. Happy learning. I will see you tomorrow. Thank you.